All right, so just a review from last time. If you recall, our wireless signals is made up of two components, frequency and wavelength. Okay, frequency is how often something occurs per second, represented by hertz. So 50 hertz is 50 times per second. And then wavelength is the actual distance between each cycle. So this is considered a cycle from this peak to the next peak. So it's measuring the length, which is why you see it represented in some form of meters. So a kilometer, really long wavelength. And wavelength and frequency are inversely proportional, meaning as one increases, like this is a huge number, the other one becomes smaller. Does anyone remember the equation to relate the two?
The speed of light written.
Yes, speed of light is in there. Speed of light is a constant. So that doesn't change, right? Speed of light stays the same. And we represent speed of light with c. Speed of light equals, okay, wavelength times frequency. This is lambda. Lambda is the symbol we use to represent wavelength. So you can see because c stays the same, if you increase this one has to decrease, right? Yeah, think of it like, I don't know, like a box of stuff. If you take away things, you have to add more so it still stays the same weight of the other thing. So okay, so you can see right here things that are high frequency have a low wavelength like X-rays down here, and then low low frequency and long wavelength has it's gonna be like your AM, FM radios, things like that. Okay, so when you know one number, you can find the other. This is a fixed relationship because of this equation right here. Okay, so speed of light in this case is 3 times 10 to the 8 meters per second. We looked at it last time. If light was to go around the Earth, it takes less than a second to go around the Earth. That's how quick it is. Yeah. So very fast, and that is a constant. Okay. And then we are typically dealing with these three different types of frequencies because they're unlicensed, meaning anyone can use it. You don't need a ham radio license. Okay, so 2.4, 915 megahertz, and 5.8 gigahertz. Now, this is for the US. Okay, the US countries will use different things, although for compatibility, we generally have somewhat the same frequencies. Just the range of it may be slightly different, right? We looked at it last time at the chart. The EU has a little bit of a tighter band than the US, right? So I showed this last time. You can see this EU orange bar is tighter than the FCC here in the US. This is our open frequency right here. Okay. Does anyone remember what this chart shows you? Well, what frequency are we dealing with here? It says at the top, right? So you can see 5,650 megahertz. Okay, let me just write this down. 5,650 megahertz, which if we were to convert to gigahertz, okay, there is 1,000 megahertz to a gigahertz. So how many gigahertz is that? Yeah, exactly. 5.65. Okay. So we're looking at 5.65 down to about 5.95. I'm gonna say that. 5.95. So you see when I talked about earlier 5.8, that's just the middle number. It's kind of the generalization. It's really in reality there's a range. It's not just exactly 5.8 is the only open frequency. We just say that, oh yeah, the 5.8 frequency. But you can see it spans a range right here. Okay. So what we're showing here is for your video transmission. Video transmission, we typically use 5.8 because we have more data we're trying to transmit. Okay. So higher frequency, we can transmit more data compared to the lower frequency. The lower frequency has the benefit of a larger uh, range. Okay. It can go farther. All right. That's why you see in this previous graph, things like AM radio, FM radio, we use that for sending our news and music. We don't use, X-ray to do that. X-ray is very short distance. Uh, so that's why we use the 5.8 for video, because compared to the other wireless signal we're sending, which is the control signal, video is a lot more data, right? Do you guys agree? Yeah. Uh, so we want to separate it out because we don't want to have interference between a video signal and the control signal. We want to have it. We want to keep them separate. So that's far enough apart that you won't have any issues. Okay, so narrowing down to the video 5.8 gigahertz, which is we're looking at right here. You can see that we have multiple. These are kind of like presets if you think about it. The range we already determined is between 5.65 to 5.95 gigahertz. But to make things easier, instead of calling out, I'm on 5.725 gigahertz, you can just say, I'm on A band number 8. Okay. You can say, I'm on A band number 1. So as long as you are on the same band, you can know that, okay, you're not on the same frequency. Okay. Yeah. All of these are tied to a specific frequency if you look. But having these kind of presets allows you to quickly determine if you are going to potentially interfere. Uh, the most popular band is the race band. You can see right here the R band. Do you see why compared to A, B, E, F, I? What is the R band's nice about compared to the other ones?
No overlap.
Yeah, there's no overlap, right? Because if you look here, like at the B band, 1 and 2, even though they are different frequencies, there is an overlap because the shape right here that you see right here, this kind of curve, it's just like I mentioned this previously when you tune into a radio station, if you go like zero point 0.3 off or something, you'll still hear kind of staticky of the target radio station. So that's kind of what happens. It's like there's still some bleeding over. So this is the problem with these other bands is that there's a little bit of an overlap right here. So the risk that you might interfere is pretty high when you use neighboring bands compared to this one. You can see right here. Even so, though, you still want to try to avoid each other as much as possible. So let's say you have 3 people flying. It's best to do like a 1, 4, 7 compared to like a 1, 2, 3. Like just try to keep yourself as far as possible. And that's what this thing is saying right here. If you look down here, this is saying, hey, depending on how many pilots you are, try to space yourself out accordingly. You see right here? So this is 4 pilots. It's pretty well spaced, except for right here. I don't know why this one's closer. And then 5, the spacing becomes smaller between each pilot, but there's still sufficient spacing. Okay. A, B, E, F, I, R, these are called analog. video signals. Okay, and that's why you see a curve. The other ones down here, the DJI, the Walk Snail, some of these other brands, they use the digital. So digital is a very defined signal. You either have it or you don't. Okay, so with analog, as you get farther away, just like when you're driving with the FM radio, it starts to get staticky, it starts to break up. You start to notice when it's going bad. With digital, you don't get much of a warning. It just kind of dies, all right? You might get a little bit of a lag. That's kind of like your warning. But other than that, it just either works. You either see your signal or you don't. So that's why there's not really a drop off, okay? It just, yeah, it's a very defined target frequency. With analog, you can use whatever hardware from whatever brand. Okay, analog is just spitting out the video at that particular frequency. Digital, on the other hand, you have to stick with that manufacturer. So if you're using a DJI 0304 system, you're gonna have to use a DJI goggle to see it. Okay, even though there are different systems in digital, they're not cross-compatible. Okay, so that's why previously for those that are building your own drone, I suggested you just stick to analog because digital has that, it kind of locks you into a specific ecosystem. Okay, and if you don't know yet and you're just starting off, you might end up getting locked into an ecosystem that you don't tend to continue using. Not to mention digital is also more expensive. So analog is a little bit more of uh, a more affordable if you make mistakes, that is. Uh, so so yeah, that's what this chart is showing you here. You see, we have our range 5.65 to 5.95. You can be somewhere in between there. And we have analog, we have digital. It just depends if you want to standardize on one particular band, which is just like prefixes, compared to another.
So are you choosing these bandwidths on your goggles?
Yes.
So you've got it,
Well, okay, so if you're using an analog, you kind of tune in to a signal just like you tune in a radio.
and it'll just find it.
It will usually latch onto the first available signal. So then if there's multiple people flying and you're scanning, it will just latch onto it'll go down it'll go down the different rows and columns and it'll find the first available thing. It may not be your drone, which in that case you say continue scanning. Or if you already know what particular frequency on, you can go to that particular frequency. Yeah.
Your goggles have smart audio though, you can set it.
Yeah,
And then
exactly.
you do the like throttle in the middle,
Yes.
go to the menu and set it.
Right,
Like,
right. Yeah. But like so that's like if you want to change your frequency on the drone. But if you're just trying to get the goggle to tune into your frequency, you can either scan or you can select the particular frequency if you know what it is.
is the drone built in with a specific band on it?
Uh, it has no, the whatever VTX you get, it usually, if it's analog, we're talking just analog, you can choose what frequency you want to be on. So that's what he was talking about earlier. You can use smart audio, which is a way to modify the signal without having to like go in and plug into a computer. But yeah, it will allow you to set your signal to one of the analog ones. Yeah, because you need to be able to change it in case you're flying with someone else and you need to separate yourself out, right? You need to be able to change it. And then later on the goggle, which is a whole separate system, you need to find that frequency. Yeah. The goggle doesn't automatically change when you change your drone. When you change your drone frequency, you have to find it again. But if you know what you change your drone to, you can set your goggle to that same frequency. If you don't, then just scan, and generally you'll know which drone yours is because, like if you're flying it or you're on the bench top, wave your hand or something. You can find because well, right now the drone kit that we use is digital, so you don't have that issue. But with analog, you might be looking at someone else's drone, and then you would have to like go to the next channel. Yeah. Digital requires kind of a pairing, so it's not so much of something you can tune into, like you can with the analog. Yeah. So yeah, so just think of it, I keep going back to the analogy. Just think of it as like the FM AM radio. Yeah, the particular radio station is broadcasting at that particular frequency. That's how we know it by, right? I don't know. What's Kiss FM? I forgot. I was like, I haven't listened to radio in forever now, so it's like, but I know that was like that's like one of the local, what is it? 102.7, yes. Okay, that sounds familiar, yes. 102.7, yeah. So that's talking about the frequency. Okay, and then you go to 102.7 and you can expect to see that one. Yeah. So yes.
So there's a lean here in trying to get away from somebody else's frequency, but on the inverse, is there any would there be any reason where you would want to be on the same channel? Like if you were flying and I want to see what you're seeing,
Oh,
is that
well, that's different. Okay, so you don't want to put two drones on the same channel. That's gonna conflict. But if you want, it sounds like what you're trying to do is tune into someone's channel to spectate and watch. Yeah, you can do that. Yeah, you can have multiple people watching the same signal, just like multiple people are listening to the same radio station. It's because the drone is broadcasting openly to anyone to as long as you can pick it up, you can watch what they're doing.
and then on the
Yeah.
inverse, like let's just say I was flying with my brother.
Yes.
I wanted to screw with his drone.
Oh, okay.
Would that, or like my neighbors
Oh, I see.
pissing me off, can that happen? Can I?
So if you set your frequencies to the same as theirs, and assuming your power is much higher, you can screw with them.
You can
Yes. Exactly.
they'll drop out of the sky like a rock.
Well, this is talking video signal, so that it shouldn't impact the drone's ability to fly.
You can ask about
Okay.
who did that to him and his drones at the bottom of the
E
ocean.
even a video signal?
Yeah,
You can
they
control.
blew out his signal and his drones at the bottom of the Huntington.
Oh, it's because he can still control it, but he just couldn't see it anymore. Okay, so that's where you screw them, where they still have control, but they don't know they don't see where they're going anymore. So in a way, you kind of screw their ability to fly. Unless they have a built-in return to home GPS, then they can activate that and blindly like still get the drone back. But most drones that we have don't have that. Like the ones that you guys are building. Yeah. So, but if you can add that as an option, you can add a GPS rescue, and then you can like if that ever happens, you can still control the drone. Because remember, our control is on a different frequency, right? It's at 2.4. So if someone blows you on the video, you can still control the drone, even though you don't know what's going, you can't see anything. But then you can activate the return to home and then like retrieve your drone at least. But yes, you can screw with someone by setting yours to the same frequency and especially putting it at a higher power, which overpowers their signal. Yeah. If yours is at a lower power, they may get a little bit of interference, but you may not completely like mess them up.
Is that
Right.
right? And I don't know if this
Mm.
is true, if the war drones like have like a wire attached to them.
Yeah. Yeah, exactly. Because wireless can be so there's multiple ways you can like mess with the signal. You can jam the signal. Okay, so you can like yeah, you're sending a bunch of gibberish and you're trying to overpower it. Or you can try to hack it. You can like actually try to take control of it. But with the wire, you can't do that. That's why they use the fiber optic drones. But those are like kind of a kamikaze one-way mission. So they don't care that because if you try to fly back, that wire can get tangled, right? But since they're only going one way, they don't they don't really care. Yeah. Um,
That totally.
yeah. You guys know like those drones, the one that have fiber optic, it can go like really far. Yeah, it can go like 10 kilometers, which is like 7 miles or something like that. Like something they got even longer ones. And the fiber optic, it's like a spider web strand, very, very thin. So, but okay, so here, let me just pull it up. Fiber optic drone. So you can see they carry the spool underneath. Okay, yeah. This is actually it creates an environmental problem also because then look, you get like things like that, okay? But I guess in war, that's what they don't care so much about the environmental. So you can see right here, this is like I wish this image was bigger. But it looks like a bomb, but this is not a bomb. This is just a fiber optic spool. Um, Let me see if I can. Oh yeah, you can see right here, 20 to 40 kilometers. I'm grossly underestimating this. And it's only gonna weigh like maybe 2 pounds or something pretty light. Yeah. Um, yeah, so they're using that, in the wars. Yeah. Detect them, yeah. But okay. But can you still mess with it? That's the thing. You can detect the presence, but then like, yeah. So the only thing, yeah. I mean, the only thing is now if you cut it, then yeah, they lose their signal. Uh, but this is not power, by the way. Power would be too heavy. They still have an onboard battery. This is just purely communication, which is very lightweight, if you think about it. Yeah. So yeah, so this is how they combat, tampering. They can use a physical wire. Yeah. Uh,
Next semester.
yeah, that could be a nice project to make for the future. Yeah. Mm. Cool. So, okay, we talked about this where it's like looking at the big picture. The FCC has allocated certain frequencies. So we're just looking at narrow bands of like 5.6 to 5.9, 2 point whatever, like 2.2 to 2.6 or something like that. So we're just looking at specific bands. But there's a lot more out there. They've just been allocated out. All right, so this is like an example. This is just showing you the different bands and their assigned frequencies. But you can see they do fall within this range that I was talking about right here, these signals, okay? It's just how you want to preset, whatever preset you want to use. So race band is the most popular one, so you can easily say, hey, I'm on race band channel number 1. I'm on race band channel number 4 and number 8. You can just announce that, and then everyone can like easily know that they're not going to be interfering. Instead of saying the numbers, you just say that. Okay. Yep. Talked about this already. All right. Awesome. Good. All right. Do you guys remember there's 3 different types of protocols? So we have the protocol, which is like a language that the data is being transmitted. So there's a wireless protocol that goes from the controller to your receiver. Then there's the wired protocol from the receiver to the flight controller. And then there's an ESC protocol. Does anyone remember the transmitter protocol that we're going to be using primarily in this class? Yes, HTX. There is other ones as well, but this is going to be the or sorry, that's the radio Express LRS. That's the radio firmware. So it's a radio firmware. That's the firmware on your actual drone, okay? Uh so not a protocol, but yeah, just the firmware to be aware of because you'll probably hear a lot of these terms and it's just like what does that mean? So that's why I want to try to break it down. So this is the wireless protocol. Express LRS. Okay, there's other ones you can see right here, and this doesn't even include everything. I'm just listing some popular one. And you can see the protocol, you also need to specify the frequency. Okay, because the same protocol you can transmit on different frequencies. All right. So just make sure when you buy specific receivers and controllers, you are buying that protocol and that frequency. Make sure you match those two up. Okay. Okay, what about for our uh receiver protocol. That was our transmitter protocol. What about receiver protocol? Does anyone remember? No, that's our transmitter protocol. That's right here. Yeah, that's the CRSF right here. Yeah. So CRSF is used by multiple different type of transmitter protocols. You can see right here. So this is the wired communication now, CRSF. Okay. You can see there's a couple other things as well. This is old school down here. PWM, pulse width modulation. This is like, actually, I have one right here. This here, let me pull it up on this camera. This receiver is the type where this receiver is the type where you have one cable for every single channel. You can see right here. So you plug in a cable for every single channel. This is old school style. And they can see right here, PPM, that's like a slightly upgraded style. What does that stand for again? Uh, I'll look it up. PPM. No, that's not it. For what is that? Oh, pulse position modulation. Okay. Yeah, so there that one allows you to just use one cable. And then all these other ones are like one cables, okay? So yeah, this one just wanted to show you a couple examples. So this is a this one actually can support multiple different wired protocols. It has PPM, PWN, and it also has iBus, which I don't see on here. But yeah. Okay, so that's wire protocol. And then finally, we have our ESC protocol. That's the D shot. That's what we're going to be using in our class. Okay, that's how we talk to the motors and how we send the signal. All right. And within D shot, there's actually multiple different types, 150, 300, and 600. All right. Any questions on the wireless frequencies? Okay. Now I'm going to review high level the antennas, which I sent you guys in the video. Was that reasonable or too much?
I thought the guy was good. He broke it down pretty well.
Yeah. So that guy is Josh Barwell, if that's what you're. There's actually two different channels I pulled from. There's one that was like only like the two-minute videos, and then there's the guy with the glasses talking for like 30 minutes or 15 minutes or whatever. That's Josh Barwell. He's a good guy to follow on YouTube. He has a lot of good videos out there about FPV and drone stuff. Okay, so definitely I would follow him. And then the other thing that I posted is another good guy to follow. It's Oscar Lang. Now, this guy only writes articles. So that's the difference between Josh Barwell and him. So this is Josh Barwell. Let's see if I pull up an image. Yeah, that's him. This is a young version of him. I think he's like completely bald now, but yeah, but he's very good expert. And then Oscar Lang is like kind of a faceless blog writer. I don't really know what he looks like because he doesn't do YouTube, and Josh doesn't really do much blogging. So anyways, those are two people I get a lot of my info from. Thank you to them, because otherwise they're on top of it. So all right. Since we already talked about wireless frequencies, now it makes sense to talk about the hardware in which we transmit and receive, and that's going to be antennas. All right. Uh, there's direction to think about, so omnidirectional or a directional. There's polarization. We have linear or right hand, left hand polarization, and then the type of connection. Okay. So there, the way that you transmit the signal, you can either do it omnidirectional, which means it's going to send it in all different directions, or you can do it directional. So if you recall from the video, we use gain as a way to tell how much power is being directed in a certain uh, direction. Okay, so if you have a gain of 0 dB decibel, okay, that means that it's not that it's like there's no power or anything. It's just saying that it's not focusing in a particular direction. Okay, it's omnidirectional. That's what 0 dB is. When you have any form of dB, you start to focus your signal to a certain direction. So I like how Oscar put a visual of a light to give you an analogy of how this works. If you just have a bare light bulb, light goes in all directions. That's your 0 dB omnidirectional antenna. Okay, and then if you have a flashlight, like one of those is like one of those mag lights, okay, right? You can turn the thing and then you can focus, or you can make it a wider beam. Okay, so that's like turning up the dB. Okay. And the thing to note is uh decibel is on a logarithmic scale, which means what we're used to normally is linear, right? We say one, two, three, and that is separated by one, right? But when we say 1 dB, 2 dB, 3 dB, it's not linearly increasing, it's exponentially increasing. Okay. Uh, so I have a chart here later, but for example, 3 dB is actually doubling your power, okay? So going from 3 to 4 is not just going to be an increase of 1. It's going to continue to get more and more increase. So let me show you here. So if we look at this chart, this is a screenshot from that YouTube video. So you can see right here, the red is what we're typically used to on a linear scale. Okay, so if we increase dB, let's say from 0 to 10, the power goes 0 to 10, 0 to 20, 0 to 20. Okay, but we're using the logarithmic scale for decibel so that we can express much larger numbers with a smaller number. So you can see right here, logarithmic scale from 0, okay, see right here, from 0 to 3, the power has increased from 0 to 2. It's doubled. From 3 to 6, it's quadrupled. Okay. And then if we want to do 8 times is going to be something around like here, dB9. Okay. Okay, look at this. dB15 is 32 times larger. Okay. So you see, because we're dealing with much larger range of power, instead of writing 1,000 times, you can write 30 dB. Instead of writing 31,000 times, you write 45 dB. Okay, so that's why we use the logarithmic scale to represent this. Okay. So yeah, just keep that in mind. It's not and also the video mentioned how dB is a unitless like scale. You need to still tie that to something, right? Uh there's the dBi and there's the dBm for power and uh isotropic isotropic yeah, direction. All right. Okay, so we'll start here. You can send the signal actually comes out as electric and magnetic fields that are for linear polarization. They're in a 90-degree offset. You can see right here. So this red line represents the transmitting antenna. Okay, so it's transmitting the electric field. And then if you want to receive that, you need to also orient your receiving antenna in line with that. Okay. So electric field is what we're trying to listen to. If you have the antenna like this horizontally, then you also need to have your receiving antenna horizontally. Okay, so just focus on whatever the electric field is. But just note that there's two components to it. There's an electric field and a magnetic field at a perpendicular orientation. Okay. So that is for linear polarization, where if you were to turn this and look at it head on, like down the line, it's just gonna look like a line oscillating up and down, like this right here. You can see this animation down here. The signal is just being sent linearly. Okay. We also have a circular polarization, and that's to try to address the issue of, well, what if your antenna is offset from the transmitting signal? Then you're going to get a lot of signal loss, right? So the circular polarization addresses that issue by sending out the signal in a corkscrew. Okay. Now, being a circular direction, there's two types of, you can either do clockwise or counterclockwise, which in this case we call it right hand circular polarization or left hand circular polarization. You still need to consider what the circular polarization direction is with your receiving antenna. It needs to be the same, okay? So with the linear polarization, you need to make sure you orient your receiving antenna the same as the transmitting antenna. Okay, that's the catch here. With circular, you need to make sure that your direction is the same on both the transmitting and the receiving. Okay, if you recall in the videos, there's not a superior one, right? Left hand versus right hand. It's just that you need to match them. Okay. If you don't match them, then you're basically you're gonna have the same issue as the linear where you're kind of offset. You're not gonna be able to hear the signal. Okay. This is an example of what a left hand versus right hand is. Okay. Usually there should be, this is actually usually encased in some plastic, although not always. You might see it bare like this. But yeah, if you're going to use one, make sure you get the same one for your goggles and the drum. All right. Sometimes they are marked, so then you can also look at that. Okay. Okay, and then a linear would just be something like this. All right. It'll just be like a straight antenna. There's different forms as well. I think a T is linear. Yeah, yeah. I'll look that up, but I'm pretty sure it's linear. I'm pretty sure it's linear, yeah. Okay, now we're talking about the direction, which I mentioned previously, right? This is omnidirectional. What this is showing you, this donut, okay, this is the signal strength visualized. Okay, so the antenna is in the origin, which you can't see. It's hidden right here, but it's sending out the signal, but it's not a sphere. Okay, there is kind of a dead zone, which is immediately above and below, like in this pocket right here, and then this other pocket that you can't see right here. Okay, so the donut hole. All right, that one's the dead zone. Okay, so that is the thing to note when you are using a omnidirectional, is that if you're flying and you're sitting right here with your omnidirectional uh, goggle, okay, you want to avoid flying over you. Usually it's not a problem that you're flying under you because you're on the ground already, but if you're flying over you yourself, you may get into this dead zone, okay? So just try to stay horizontally away from you. Okay, so the good thing is you can kind of fly in any direction, equally distance, and as long as you're in the general donut zone, you should be okay. This is Josh Barwell's video. That is splitting it. So you're looking at in two ways, okay? The horizontal is you splitting it like this, and then you're looking at it top down. Okay, so that's what it's going to look like. It's just going to look like a circle. And this is what the benefit of an omnidirectional is, right? You're here in the middle. It's radiating outwards equally in all direction. So it doesn't matter if it's the drone is to the north of you, south, east, west, whatever. You have the same amount of signal strength. Okay. This vertical is now chopping a donut like vertically, and then you're gonna look at it, okay? And then this is what I mean here. There's the two lobes, okay? And the dead zone's right here above and below. Now you're right here, so really there's a ground. There's a ground that is let me see if I can draw it. Okay, so the ground is actually like right here. Let me make this darker. Okay, this is the ground, the purple. Okay, so you're really only dealing with the top half because you're not going underground, okay? So you can see right here, the danger is if you fly directly over you. So you're standing right here. You can fly around you, but as soon as you go directly over you, you can get into this dead zone. Okay. If you are super close to you, it's okay still. It's not like it's a you see, it's not like a true donut where it's a channel that goes all the way through. It's just that the signal drops. So if you're close to you and you fly over, you should be okay. But it's the danger is if you fly higher up, like right here, then you're in a dead zone. Okay. So it's just in general good to avoid flying over you. Do you guys get this image? This is a cross section of that previous one. Okay. Yeah, so you guys see that? Okay. Yes.
In the video, you mentioned that, depending on the type of device or
Yes.
the material, or whatever you're using, that the donut could flatten.
Yeah.
But I didn't understand.
Oh, yeah. Yeah. So if you were to if you were to increase the what was the term he used? Yeah, I think it's if you, I want to say if you increase the dB, the decibel, because it's omnidirectional, so it's not like you're aiming toward a particular thing, but you can get farther signal. But what happens is the donut squishes. So it bulges out the sides. So what's gonna happen is, here, let me copy this and write it here on the iPad. Because yeah, he didn't show it visually, but I can mentally see what he was trying to say here. Let me see if I can.
Now, is this static, or does the donut change if I'm like whipping my arm around with the controller? Like, am I changing the dead zone?
Oh yeah, so like with your antenna, this is assuming your antenna is just pointing like that upwards. If you go like this, the donut goes with wherever the thing is. So if you go like that, then yeah, you're going to change the orientation. Yeah. So yeah, good question. Just so you are aware. All right, let me see here. Okay, so you can see that what happens is when you I have to look at it again, but I believe you're talking about the dB. When you increase that, it's gonna get farther like this, but it's gonna get a little bit more squished. Okay, so then this is also going to get bigger if you're looking at from the top. So he was saying the danger is okay, so the compromise is yeah, you get farther signal, but then your height starts to drop. So you have to be careful about flying like too high. Like previously, if you're right here, it would have been okay, but then when you increase the dB, then
Oh, your ceiling is lower.
yeah, your ceiling is lower, but your width is bigger. So you're squishing the donut and it's bulging out the side. That's what's happening. Yeah, you still have the dead zone right here though. You still have the dead zone, but now your available height has also been decreased as a result. Yeah, that's what he was saying. Yeah. So he's saying it's not necessarily better if if you are not planning to fly that far, you don't necessarily need the higher gain antenna. Yeah.
Okay.
But yeah, and if you do need it, you just have to keep in mind that it's not as high anymore. All right. Okay, this is a directional polarization. So he was saying about this earlier. The 3 dB, remember that means that's the signal when it doubles, okay? But in this case, we're seeing that when he says the width, that means that that's when you lost half of your signal. So outside of this beam width, you have lost half of the signal, and it gets drastically worse as you go farther away, okay? But it allows you to get farther out than if you were to just have an omnidirectional, okay? Uh, this is looking from the top down. This is like our horizontal thing that I had previously. This is the equivalent of this thing right here. Okay, this is looking from the top down. Um, but yeah, so directional is good if you only plan to fly away from you in a certain direction, then you can choose a directional and then aim your signal so it goes farther in that one direction. But it gets dangerous if you try to fly outside of that beam width. Okay, so you just have to plan accordingly. Yeah. So omnidirectional, I guess, is good for flexibility if you want to fly wherever you are around you. But if you only are flying away from you in a certain direction, then you could use a directional. Yeah, perhaps good for like people doing long distance flying. They only intend to fly in a certain direction versus people that are casually like racing where they can fly all over the place. Yeah. Okay. All right. So dB loss, okay. So we want to try to prevent any signal loss, okay? And you do that by using the same polarization, right? So linear with linear versus circular and circular. Um, and then also this is assuming you have the right orientation. So linear is in the same orientation from the transmitting and the receiving, okay? And also the right-hand circular polarization is being used with the right-hand circular polarization receiving antenna, okay? Then you have a 0 decibel loss, okay? But if you start to mess things up, right? So vertical to horizontal or the linear, you're going to have major loss, okay? Remember, this is not just like 25 to 30 megawatt. This is a great order, like 1,000 milliwatt, okay? Remember dB. So yeah, so these are the scenarios. Um, vertical versus horizontal, vice versa, or left hand and right hand polarization, vice versa. Okay. Circuit, you can mix circular to linear, and there's a little bit of loss, but it's better than if you're to use the same one that are different. So yeah. Okay. And then the other thing is for linear, going back to linear, because of the issue I talked about, right? If your antenna is 90 degrees between the transmitting and the receiving, you're going to have this big signal loss, right? 25 to 30 decibel. This is why we have what's called a diversity antenna setup. So like this thing, for example, you see there's actually two antennas. Now this one's kind of floppy all over the place. It expects you to mount it 90 degrees to each other. The idea is if your antenna, if this is the transmitting antenna and now this is like this, okay, this one's going to be good. This one's not going to be good. But then later when your drone moves around and now this one's the better one. Okay, so it's kind of like making sure you covered all your bases, no matter the orientation. All right, so that's what this diversity is. That's why you set it at 90 degrees so that you can cover all those different scenarios. Okay. I mean, you could still like cheaper drones still just fly with one antenna. That's fine. You just notice it's a signal drop. So if you're close enough, then you can still catch it. But if you're trying to reduce any loss, especially as you go farther, it's good to have the linear diversity. Okay, that's why you might hear diversity antenna. That's what they're talking about. All right. This is a summary of some things to keep in mind with antennas. Okay. You need to make sure your polarization is matching. So don't mix right hand with left hand. Okay. Because as you saw earlier, we can get 25 to 30 decibel of signal loss. All right. The other thing is carbon isolation. So keep it away from carbon, which is conductive. Okay. So that could potentially absorb some of your radio frequency. That's why you see the antennas sticking out. All right. They're generally sticking out. Aerodynamic alignment. Okay, so drones when they're flying, they tilt forward. Okay, we're talking FPV drones. Okay, they're typically tilting forward and you're flying forward. So just like your cameras, you need to orient it in anticipation of its normal flight angle. Okay, so your cameras on the drones are typically pointed upwards because when you start flying, you're going to tilt forward and then the camera is going to look forward. Okay, so likewise with the drone antenna, you also want to tilt it back a little bit because that way when you are flying forward by that same amount of degrees, it's now vertical. Okay. So this is all optimizing for forward pitched flight. Okay, and then also avoid any heavy TPU thermoplastic. That's like a type of 3D printing material. Okay, it's just that's why sometimes you see the antennas are just bare covers. They have these covers for kind of protection, but it could also interfere. And then, as I mentioned previously, specifically for HD, you need to make sure you use the same ecosystem. This doesn't have to do anything now with the antenna anymore, but it's rather just to make sure your system works. Okay, HD has the compatibility with specific brands versus analog can be whatever brands. You can mix and match all you want. Okay, analog is just using open frequencies available to everyone. Okay. Any questions on antennas? All right. Shall we look at the quiz then? Let's take a look at the quiz. Just to see preview. All right. So main job of the antenna. You can feel free to call it out. Yes, transmit and receive electromagnetic waves. Okay, great. What's our two components? Yep, electric and magnetic fields. Okay. Well, I didn't mention it just now, but it was probably in the article or the video. Do you guys know what how does the antenna length change depending on
Is relative to the signal.
it's relative to wavelength. Yeah.
Right.
So like longer wavelength needs a bigger antenna. Okay. Yeah.
Is this is that the reason why like there's like some places in the world where they have like antenna size of like mountains or something?
Yeah, like those
Where like the satellites in space.
Yep, exactly. Yeah, so that's why for those long distance signals that we talked about earlier, right? Longer wavelength is uh Longer wavelength is smaller frequency. That's used for you can transmit farther. Okay, that's why we also use the lower frequency for the 2.4, the signal for the transmitter. Yeah. You guys know, like, if you notice, usually like in the desert, they tell you to tune into an AM radio compared to an FM. Yeah, because AM, if you look back at the other slide, is a longer wavelength. You can see right here, AM radio is a longer wavelength, smaller frequency. Okay, so AM can go farther. All right. The quality sucks more. Have you noticed that between that and FM radio? Like, but they're mostly transmitting like audio and stuff. But it's the same analogy with why we use 2.4 for our controller signal versus our video, because there's less data that you're less fidelity that you need for transmitting like audio, like just verbal audio versus music. Yeah. What does antenna gain describe? Yes, exactly. Remember 0 dB, that's going to be omnidirectional, all right? When you have a gain, then you're going to start to focus your your signal in a particular direction. Okay. Isotropic radiator. Okay, so isotropic means that it's uniform, or in this case, it's radiating in all directions. Okay, isotropic.
Is it, did he describe it as more of a concept, like there's no true isotropic?
Yeah, well, in reality, there's never a true like orb. Yeah, that's just like if you ever like if we measure this voltage, it should be 120 volts AC, 120.000, but in reality, it's never. So that's what he means. Like in reality, is like things are never perfect. Just like a ball bearing, the ball should be perfectly round, but if you really, really measure it, it's never perfectly round, right? Like that's just the reality of things. But yeah, it should be dBi, okay? And then dBm, that's talking about the milliwatts, all right, for power. Okay. Oh, I already said it. Okay. C, okay. Okay, 3 dB is what? Twice. Okay. 6 dB, does anyone remember just now? If 3 dB is double, 6 dB is 4 times. There. Where did I have it? I have it right here. Yeah, 4 times. 6 dB is 4 times. Okay. You see, these are powers of 2. So 2, 4. Next one be 8. So that should be 9 dB is 8. 9, and then 12 should be 16, and then 15 is 32. Okay. All right. It's log base 2. That's actually specifically what it means, log base 2. Okay, what happens when antenna gain increases? Yeah, more focused in a particular direction. This will be the opposite when the antenna gain decreases. And then it's not to do with the power. That can be a confusing topic. Okay, antenna gain, analogy. B, common radiation shape for a omnidirectional antenna. Donut, yes. Yes, above and below. Okay, typically we only concern about the above because assuming you're standing on ground.
Like
But
flying on a bridge or something?
yeah, I guess if you're flying on a bridge, that could be a concern too. Yes, that would be it. I was thinking, I seen a video of someone doing FPV from a hot air balloon. Like, have you guys seen that? Like, they're filming themselves. I guess you would have to be concerned about flying below you too. Yeah. Yeah. That looks pretty cool though. Why should you avoid pointing the tip of a simple antenna directly at the drone? You shouldn't go like this. All right. This is actually, they have a hinge here on purpose. You should be holding it like this. Now you know the donut orb is like this, okay? All right. So why?
The
Yes, exactly. The tip, the signal is going to radiate like this, okay? So the tip is going to be your dead zone. All right. Directional antenna, what's the main advantage?
Range, right?
Yeah, it's B. So if you know you're going to be flying in a specific direction, you can increase the range in that one direction. Yes.
C.
It's C. So you can get the best of both. You get omnidirectional, you get directional. So you'll sometimes see like someone with a patch antenna and then like another like circular polarizer antenna. Yes, that's what you have. Yeah, that's what I have on my analog goggle as well. Yeah. So that's why you see two antenna ports, or at least two. Okay, antenna polarization. Yes, very good. Okay. What happens when a vertical linear antenna is paired with a horizontal? Yeah, polarization loss 25 to 30 dB. Okay, which is why we have diversity. Okay, right? We have diversity for that. Why is circular polarization useful? Think of it, the signal is traveling like this versus like linear line. Yeah, it's less affected by the drone orientation. But remember, you have to use the same type of circular direction, all right? It's either right hand and right hand or left hand, left hand. Okay.
Well, C.
Yes, exactly. Which one's best for circular? Yeah, the one that matches, okay, right here. These are bad. This is actually negating. So you can actually use this to your advantage if, I mean, besides using different frequencies, you can also have pilots on different polarizations, okay, especially for neighboring frequencies. All right. You can have, like, let's say you have a lot of people flying, okay, now your gap between the frequencies are less, okay, so there's a bigger chance you might interfere. You can have every other pilot use right hand and then alternate with left hand. So that further helps prevent any interference. So you can actually use the fact that right hand, left hand don't really work well with each other to your advantage. Okay. Yes, exactly. Which again is a good thing for the scenario I just described. All right. Good job. 40 out of 40. All right. Um, hmm?
So with interfering, let's say in a scenario where there's multiple people flying in like a smallish area
Mm-hmm.
and you haven't changed the polarizations, everybody's kind of have the same polarization. So can one signal from a single remote affect multiple drones at once, or is it only one at a time? That is like disrupting one grid. Like, does it tune to like, can it tune to multiple receivers or just one receiver at a time?
Oh, this one's goggles, so the receiver is a little bit different, although that can have its own interference. But we're talking the video is generally the more susceptible interference, just because it's a wider band. There's more bandwidth that we're using, and it's more of a like a public open signal compared to like with the controllers and digital goggles. You typically have to pair them, so then like if they're not paired up, even if you're trying to use a very similar frequency, it won't sync up and talk. So if we're looking at the goggles, okay, so let's frame it in the case of the goggles. You're asking if you had someone using the same frequency, would that impact everyone or just the local. It would just impact the local, the ones that are like in that same frequency range. That would be the ones.
Better than more.
Yeah, if they were close enough to that frequency, yeah, it would impact them. But you wouldn't impact people outside of your range. So let's say right here, you're on R4, okay? You'll impact people in this general column right here. Yeah. But you're not gonna impact someone like out here or out here as much. Yeah. But then having a different right-hand circular polarization, left hand would also further prevent too much of a disruption. But in the end, like it's not that you can't ever see the signal, remember? It's just a major power loss. So if your disruption signal is still loud enough, it can still get picked up even if you're using right hand, left hand, right? So this is kind of like earplugs and it just muffles it out, but you can still hear if it's loud enough.
So is there anything outside of racing where that would really be a problem?
Well, these VTX is used for more than just racing, so it would still be the issue if there's multiple people flying at the same time. Yeah, I just use racing as an example because typically that's when you see that. Yeah, you'll have multiple people flying at once versus like if you're just doing an inspection, typically you're not going to have multiple drones going on, so there won't be as much of an interference. Yeah.
How do the jammers work, like phone jammers? Is it just like?
Yeah.
setting the frequency?
You can either overpower, you just be really loud, right? Like just like if I was to talk over everyone else. That's one way you could do it. Uh I think that's the primary way they do it is they just like overpower it at that frequency. Yeah, so that now the drone and the controller no longer has the primary connection anymore. It's being overpowered by that. But then that's more of just to kind of you're gonna confuse and scramble. But if you want to control, that's like a different way. That's like if you want to take control, then you're gonna have to like hack into it. Yeah. Um,
Question. So like for like the drone shows where they use like
yeah.
hundreds of drones, do they use like different frequencies for that or?
Uh, as far as my experience, having worked a couple of those, it's actually like it's like a network device situation. They actually set up Wi-Fi access points, and then it's like multiple drones, just like we have multiple devices on the same network. Yeah, they just all have they're like an assigned device on the network. They actually are not really having their signals live. They're all pre-programmed, at least the ones I'm been familiar with. They're pre-programmed paths, and the only thing is now very like light signals just to monitor the status of the drone. Yeah, so you can still do like you can't really like tell it to do much other than like kill switch. Like you could be like, okay, I need you to come back. But like you can't modify so much as like the path because that's already pre-planned and uploaded to the drone. And they are not aware of each other's presence. They're just blindly flying their own little path. Yeah. Yeah, they don't have sensors, and it's not like there's 1,000 controllers controlling every single
Kind
drone.
of like a hive mind?
Yeah.
Not
Yeah.
yet. Not yet.
So what they do is again, it's called Unity. Or you guys know about it, like the drone company. Yeah, so it's like a drone show company that a lot of drone show companies buy their hardware. Sorry, that's a drone show like hardware manufacturer. A lot of companies use them. But how it works is like they already simulate it in a computer, and then they know, okay, each drone needs to have this particular path, and then you have to upload it, and then you have to synchronize a clock. They have to make sure that they all start at the exact same time. Otherwise, you could potentially clash into each other. So there's like, it still happens. Exactly. So that one works a little bit differently because we are not actively live sending a signal to it. You just kind of send it once and you can still monitor it, but it's a very light signal once it's in the air. It's just like, hey, like green, everything is still good, or kill switch. That's kind of like the only options you have. You can just look at basic stats and then like kill it. Yeah.
Wow.
Yeah. So that one works a little differently. That's more of just like our electronic devices. Did I describe that right, you guys? Like for your drone show experience? Okay. Because I only worked a couple of those. So it's like that's what I learned from doing those stuff. That was pretty cool.
Only shadow.
Okay.
I mean, me too, but like, there's a lot of issues that can. Like,
Yes.
it's a very complicated system, you know, it's
Of
easy-
course.
it's easy,
Yeah.
But, yeah, if one thing goes wrong, the whole system crashes.
Yeah. Yeah, exactly.
I remember one time they had whoever designed the show for them, they put it in, it was correct.
Mm-hmm.
They just orientated it
That's,
incorrectly.
they
Yeah.
shifted it by 7
Oh,
degrees or something.
Okay.
Yeah, so
Some minimal amount.
Yeah, so but if you look at it, it's facing the wrong direction. It's
Yeah.
supposed to be facing,
Yeah.
and plus that show, I think it took another hour to try to get it connected, because they had to reset every individual.
Yeah.
you know.
It's a very labor intensive process. So you have to like lay out the drones and they have to be spaced exactly. Now they don't have to have the drones. They don't have to have like drone number one, drone number two, and drone number three. They can just put them out randomly and then I think I don't know, they somehow get it to like know where to send each signal.
Yeah,
Don't, or I think he's flying back today.
Oh, okay, he's working a shout.
He's been working the past like 5 days.
Oh, okay. Yeah, I guess July 4th is
Yeah, they're, I
yeah.
think they're up to, what, they're at 1,500 grounds or something?
Yeah.
Yeah, well, I think it's split up, they do like 500 at a time, but the issue is like you were saying. Kansas or something, but it flew, like, it went off course.
Oh yeah, here it is. Oh, really?
Yeah, he ended up getting an open heart surgery.
Oh my gosh.
He got Sky Elements actually. They
Okay.
Crap suit out.
Yeah. Well, the
His chest was like crushed.
oh my gosh. Well, these drones really aren't that big. They're like
It hit him
They're-
at like full speed.
Okay.
Like,
I mean, I guess yeah. But these ones just to give you a scale, it's like this big, the drone.
Like the size of the building.
It's like the size of the thing you're building. Yeah, it's not like
all it has is a light, that's literally.
well, yeah, exactly. It's just a drone with a light dome on it. That's what it is. It's similar to the ones you guys are building. But maybe like 2 pounds, something like that. But they use actually because I saw the innards of it, they use this is something I was planning to do for the advanced class. They use a Pixhawk controller right here. Okay. So this thing is something you can do more custom programming versus the thing that we're using is just kind of more manual flight. There's not so much automation.
You do like autonomous flying on that too?
Yeah, this thing can be programmed to doing a lot of autonomous and data capture and stuff like that. This is a different flight controller, but the concept is still there, right? You can see like you still have all your components, ESC, things like that. Okay. It's just this is a particular flight control board that we use for that.
So if you're like a security company and you just wanted this thing to do a perimeter,
Yeah.
you just,
I would build it with a Pixhawk. Yeah.
cool.
So anytime you're trying to do something that's autonomous and not manual flight, with a Pixhawk, that's what I'm gonna end up using.
There a weight increase still?
It's not that heavy. It's just bigger. It's like the size of a phone. That's how big the thing is. Or actually slightly smaller. Maybe like this. It's maybe like this big. Yeah.
Well, 5 inch would do.
Yeah. Yeah. But this is not meant like if you're just gonna manual flight, don't bother getting this. This is meant for programming and autonomous missions. Yeah.
When you say autonomous, that's like pre-programmed.
Not necessarily. You can have it do, it's typically pre-programmed, but you can also have it do sensing. Yeah, but this Pixhawk, now that's beyond this. Then you have to get like an NVIDIA Jetson to actually do like
You use Raspberry Pi too, right?
it's still not, it doesn't have the processing capabilities. What you need is you need some onboard GPU in order to do things like that. Okay. Yeah, so this starts to increase the size and weight of your drone, right? Um but you would use this in addition to like the Pixhawk. You would talk with the Pixhawk in this. This would do all the GPU calculation. The Pixhawk would just command the drone to do specific motions. I mean, you can do cloud computing, but now that's a whole different thing because now you have to make sure your internet connection is good and stuff like that. Yeah, I think on board is going to be a little bit more robust unless you have like really good like you know data. I mean, the way to make it smaller is to do embedded hardware, which is what DJI does. They like make their own boards. So, but if you're trying to make a prototype, then you have to like build a PC, like you cobble things together and then you make it work. Yeah, but later if you're gonna like mass produce, you can like buy the NVIDIA chip and embed it directly on your own board and then the scale comes down, the size comes down. Yeah. But I'm just showing you like this is what you would have to end up doing, something like this. If you want to if you wanted to like do some very computationally heavy stuff. Yeah. Okay. Am I still
Do
recording?
you think like the industry is gonna move towards autonomous flying,
Yes.
like, exclusively?
Yes.
There's gonna be like.
Yes.
Melody.
I mean, just like that would be the ideal direction, just like driving, self-driving cars and stuff like that. Like it's if you can have autonomous motions, it's going to be more consistent, more reliable, uh and also more available. Right? Like that's why in general robotics, a lot of industries are looking at robotics, right? Like you don't have a robot calling out sick and uh taking vacation and stuff, having to sleep and stuff like that. They can work continuously.
This one, like, practically would just like create a route on, for like, let's say for deliveries. It would just
Yeah.
kind of like map in all the addresses.
Yeah. I mean, right now, just like the self-driving car legally, well, actually, even the self-driving cars, if you go to LA, there's
Yeah.
no driver in there anymore.
Yeah, no.
But they had to have like a person sitting there just for legal reasons and stuff like that.
Maybe I'll just to name that one, but they're like UGVs, unmanned ground vehicles.
Yeah.
They deliver like foods.
Oh yeah, I seen those things. Yeah. Yeah. Exactly. I mean, yeah, I think right now it's still like regulatory and cost that's preventing us from seeing mass-wide adoption of those. But that is like the direction we're going. So the way I see it is if you want to stay on top of it, you learn how to do the autonomous systems. Because knowing how to fly a drone is nice and all, and they're still needed in specific situations. But I can foresee how this thing will get very like a lot of drone applications will get automated. All right. So um yeah, that's a focus I'm gonna have for trying to do the advanced classes, like do more autonomous programming of the drones, because I think that's gonna be more useful. Like building a drone is a baseline skill, but what you do with it later, I would push more toward the autonomous.
There'll be a class where you have us build drones and then.
Yeah, that's the advanced.
At the end of
That's
the program.
Well, no,
light
the
show?
build, oh, light show. Oh, that's all. They have a company with hundreds of people doing that. This is like, that's not something we can cover in a class like this. But having the ability for you to program like basic waypoint missions, that would be the point of that class. Yeah. Or you can even put on like an obstacle avoidance sensor and have it be able to avoid walls. Like maybe not fly on its own just yet, but you can have pre-planned missions and some basic obstacle avoidance. That would be what I would focus on in that class.
Well, I know my drone has like a setting to set waypoints and.
Yes.
Pre-flight, I just haven't tried it yet, but.
Yeah.
Is it, it's just basically that, just like you're gonna.
Yeah.
Interface with that or?
Yeah. But you can also like, I mean, yeah, you can plot manual points or you can create, yeah, maybe you can upload like, hey, this is the area and I want you to generate a path in this area, right? Like that's where it's more than just like manually plotting the points. You would have to do a little programming to get that. Yeah.
Do you use like Betaflight for that?
No, that would be like mission ground control. That's like the Pixhawk system is different. Betaflight is what we use here, and we'll go over that today actually. Betaflight is what we use to just set up a flight controller that's meant for like primarily manual flight. Yeah. So it's good to know because the same things apply later. Is there's not really any autonomous motions with our Betaflight thing. It's just like setting up your protocols I mentioned earlier, setting up your what does this stick do? Like this is the throttle, mapping that throttle to the throttle signal. That's what you do. You would have to do that even on a Pixhawk, but the Pixhawk has additional stuff where you can do like actual programming it to tell it to do things like that. Yeah. Yeah, right. Yeah.
Good programming.
Yeah. Well, now it's not even that. It's like do Claude, do this and that. No. Yeah. No, it's still good. You need to know what to do with the program.
Do we need to take like a language class
You
like
should.
Python?
I think with the bachelor's, it actually requires you guys to do a Python or something.
Basic, yeah, the intro and advanced for Python.
Yeah, you guys need to know some stuff. Yeah, because
Week 3 of intro, and I'm like.
Yeah.
Over loops and stuff, I'm like.
yeah, but you need to know these things if you want to actually make it do certain things.
I'm trying to figure it out.
Yeah,
We can do
yeah. Very good. I think I had a slide, but let me see. There's also let me pull it up. Oh yes, right here. Let me put this in here. Okay, this one's also good to know. It's the type of connections that you're gonna see for the antennas. So for smaller antennas, like the ones that we're dealing with here in our drones, you're gonna see a lot of these U.FL. It's like a tiny little connection, and it's just like you snap it on like a button. Okay.
Like what's on the ELRS, right?
Exactly. Yeah. So this is like the type of connection you're going to be using. Just be careful with these. They're not meant for you to constantly plug and unplug. And oftentimes what happen is you can tear out the mating connection. Yeah. So don't keep unplugging it multiple times. All right. They're pretty fragile. The other type that you're going to see, which is the bigger type, like primarily on like your goggle antennas, right? This is going to be the SMA or the RPM SMA, okay? So you have to be also careful because sometimes we have a male and a female version, okay? So just look at the protruding pin on the inside, and then you need to buy accordingly, okay? So when you do buy antennas, you have to keep in mind type of polarization, the and then also the connection as well. All right. And then the polarity male female. Okay.
On the SMA part, the SMA,
Mm.
and somehow my goggles came with they're, I think both RPSMA, but for some reason, the antenna and the goggles both have like pins. But
Yeah.
they're opposite fittings, so I had to get an adapter.
Exactly. Yeah.
Yeah, that was a fun thing arguing.
Yeah. So unfortunately, not like our drone batteries, which is like female on the plug. It's not. You can run into issues because you can have the same connection, but it's a male or a female.
Oh, so it's not standardized.
Not really.
Oh.
Yeah. So just be careful. These are
I did.
that's what I'm saying. There's a lot of gotchas when you build your own drone. Like right now with the kit, we already matched everything up for you. But if you were to buy it from scratch, there's a lot of things where it's like, first, should this component even be used for this? Like example, like your motor is underpowered, overpowered, and then you have the hardware connection itself. And then also the connection to your drone itself. Is it too big? Is it too small? There's a lot of considerations. So yeah, I mean, you've seen battery connections. And now you see antenna connections. A lot of different things to note. All right.
That's a water leaning towards that UFL, but
UFL, well, this is primarily used for smaller drones. But it's fragile. It's not meant to be connected, disconnected. They shouldn't pop off on its own, right? You have to actually come and pluck it off. Yeah. Uh,
I think I've only popped mine off, but like on a hard. Like on a hard.
yeah.
Oh, dang.
I mean, if I can, I'd rather use this one because this is more secure, but this is also bigger. This
So
thing
that's
is
like
like
probably a
this thing is like this thick, like the connection versus this thing is like 2 millimeters. You see, it's tiny. It's tiny. So you'll see it on our let me see. No, the drone kit that we use actually has a built-in antenna for the actually no, the VTX uses this. The VTX uses this on the classroom kit. Okay, it's under a metal plate, so you don't see it. Because that metal plate is there to prevent that from like popping off. Okay, and then the receiver antenna is actually built into the receiver already. It's like a little square antenna. So you won't see this one. Oh, actually, you'll see this one on the goggle. You'll see it on the goggle. And we have a backpack right here that you put the antenna on. You'll see this thing as well. Okay. I haven't really come across too much of this stuff. But this is another type. Okay. Alrighty. Cool. So I think we're good on the lecture portion. Any questions? Antennas, receiver, transmitters? Okay. Is everyone mostly done building the drone? Okay. Okay, you can continue building. What we're gonna do since who's actually like done? Like the two. Okay. We'll continue building. But what we can do today is actually start looking at configuring it with Betaflight. Okay, that is a software. If you have your own computer, you can download the software Betaflight. Let me pull that up. Oh, actually,
Using a desktop version.
yeah, it's no longer, sorry, I'm in my old mind because this is how it used to be. You download it. Now they have a web app. Okay. So that means we might actually be able to use the classroom computers because
I think the desktop version is still the preferred.
it still works.
I
Okay.
mean, that's what I use.
Yeah. So, but it's not like a standalone desktop app. It's a web app now. So, yeah, you can go here and you can either do the web app, which you see if you go here, you can download that. So let me show you. This is what the web app looks like. It's like an instance of Google Chrome. All right. That's why it opens so quickly. And then the other thing you could do is run it directly in your browser. You see, it's just app.betaflight.com without having to download anything. Okay. So, all right. Yeah. So if you want to play around with that on your computer, you can try one of those Windows Surface laptops, although I think we're having trouble just even logging into those. But I can open it if anyone wants to give it a shot. But if not, at least if someone in your group has the computer, that should be good enough, even if you don't have one. Okay. All right. So we'll do that when we come back from the break. 7:20. How does that work? 30 minutes. Okay. Alrighty. Okay, so what we're gonna do, regardless if your drone is ready or not, we can start to configure the drone. I would say at a minimum, if your flight control board is on the drone. Does everyone at least have that? Even if the rest is not built out? Okay. All right. Remember, with our flight control board, we have an arrow. Okay, the arrow, let's make sure that we're pointing it forward. You see the gold arrow right here? Make sure it's pointing forward, which I don't have the camera installed, but the camera should be right here where my finger is. The camera. Okay, so make sure the arrow is pointing forward. Okay.
The USB-C, like the plug in the USB-C is on the left side of the drone if you're pointing.
Yeah, basically the USB-C should be on the left side. All right. Okay. What we're going to do is we're going to plug this drone flight control board to Betaflight. This software is used to configure all of our settings. When you plug in the USB cable, it's going to power on the flight control board, which is A, and it's also going to power on the receiver, which is I. What it's not going to power on is your VTX system, which is E and F. It's also not going to power on your motors and the ESC, which requires its own battery. Okay, so this is why we're okay with we don't need a battery for this. Okay, you don't need a battery. And as a result, we also don't have any overheating issues. The overheating comes when you are working with the VTX. Okay, the VTX is going to need the battery plugged in, and that's when it overheats. And that's when we use our fans to keep it cool. So we don't have that concern right now. All right, so plug in. Does everyone have a USB-C cable? Okay. So plug in the USB-C cable to your computer. Oh, you got some goodies. Let me take a look real quick.
I thought this one was close.
This might work. Oh, these two won't. That's a network crimper. No.
This looks like it's.
This one might work. Okay. All right. We could try this one later. All right. Okay. So does everyone have Betaflight? Hold up. All right, let me see if I can. How do I?
Oh, yeah.
All right. So it looks when you plug it in, the first time it may not show. So let me just show you. This is what it looks like. Mine already popped up. You see right there? If yours doesn't pop up, you can say can't find my USB device. And then it's gonna have this window, and you should see a line there. All right, does everyone see that? Okay, if you don't, then that's a bigger problem. But you should see something here, and then you say connect. Okay, when you connect, you're gonna be brought to this screen. All right, just go ahead and move the drone. It should move accordingly. All right, that means it's talking. I'm gonna go through each of these screens one by one in full detail. Okay, so I'm gonna start from the top at setup, and I'm gonna work my way all the way down. All right.
Is this supposed to be showing up that?
Huh?
It's not showing up at all.
Did you
I got a much different looking thing.
Okay. You're not connected yet. You're not.
I was. Here's what it was.
If you want to. That's storage.
Okay, go ahead and say
Oh, I
connect.
thought he was using the web.
All right. You guys got it in? All right, very good. What's up here? Oh, just don't download because we don't have admin rights here. We're just gonna use the built-in browser. You see how it doesn't show anything? So you're gonna say connect and then connect.
Yeah, we didn't have that.
Okay, very good. Okay. So in the setup screen here, place your drone flat on the table. Okay, and then we're gonna press calibrate accelerometer. And then you're gonna notice the preview of the drone model is going to flatten out. You see, mine flattened out. Okay. All right, very good. So now this is what we set as a 0 level point. Okay. We don't have a magnometer, which does what, by the way? Tell us, yeah, it's a compass. It tells us heading. We don't have that, so we can't calibrate it. In fact, if we look at this top bar, this tells us all the major sensors that we have. You see, we only have 2 yellow highlighted, gyro and accelerometer. These are the only sensors that we have on this drone. Okay, If we paid more, got a fancier one, we would have additional sensors, but we don't have that. Okay. Those building the Josh Barwell drone, what do you have? Are you using the Josh Barwell or are you using Classroom?
Yeah,
What sensors do you have?
I think the data came.
Oh, we have data cables. We have a bunch. Okay, anyone else have a different drone? I mean, I would think at minimum you have gyro and accelerometer. Okay, all right. That's fine. I mean, it'll work. Okay, we're not going to erase settings, and we're also not going to activate the bootloader. So this allows you to do like debugging and like firmware updates and stuff. So we'll touch that if we need to. Okay, here we have like a preview of like, I don't know, like whatever pilot instruments. Okay. GPS is not applicable to us because we don't have any. Otherwise, it would show you true when it knows its position, given that it has enough satellites, but we don't have that, so that's fine. This one's important. Arming disable flags. Okay, so do you guys know the term arming? Yeah, so arming, what that means is that's when you like basically make all the control switches live. So you can turn on the drone. Like right now, our drone is on, but if I touch this, it's not going to just randomly start flying off. Okay. So arming is now putting it like activating all these switches. Okay. So when you have arming disable, these are things that are preventing you from arming the drone. So if you're ever wondering, why is my drone not taking off? Why is it not arming? You can look at the arming disable flags to get an idea. There's a lot of conditions this drone needs. It needs to have enough battery. It needs to have a connection to your controller. It needs to have, yeah, I don't know, like a bunch of other things. All right. So if any of those are not satisfied, it's going to show up as a disable flag. We actually have 3 disable flags right now. And they may seem a little cryptic, so you can always Google it, but at least the first one kind of makes sense. What does RX mean? Yeah, receiver, and it says it's a failsafe. We haven't gone over this term, but basically what's saying is I have entered a safety mode because I do not have a connection to my receiver, and they call it failsafe, the safety backup mode. That's like your return to home mode, all right? Except this can't return to home because there's no GPS, right? But it entered the equivalent of a return to home, which is what we call failsafe. That's a general term. So that makes sense. I have not turned on a controller. I don't even know which controller mine is. We haven't paired it yet. Okay, that's something we're gonna have to do later. So that's one thing. MSP, I forgot what it stands for, but it basically means you have a USB cable plugged in, which if you're looking at it on Betaflight, that's always going to show up as soon as you're in Betaflight. So you're always going to see an MSP. And then we have an RPM filter. I think that has something to do with the motors. But again, like I don't remember, so I can look it up. RPM filter Betaflight. Let's see what it means. Okay. Yeah, it seems like it's something to do with the motors. Okay, yeah, something to do with the motors. Okay, so basically we have 3 things that are preventing us from arming or taking off the drone. All right.
We don't have the RPM.
That's a good thing. The less flags you have, that means that because you guys already set up your motors.
Yeah.
I haven't set up my motors yet. So you don't want any flag, right? Because these flags prevent you from taking off. But remember, at a minimum, you're always going to have an MSP when you plug into the computer because that's what it means. You plugged in a USB cable. That's what it means. So, okay. And then here's some other stats. We have no battery. That's why it's like basically 0 volts. And yeah, nothing's running. Okay.
Why is your RSSI at 10?
No idea.
Like mine's at 0.
Yeah. Ish. I don't know. I have no idea.
Reset the position.
Oh, so what you do is, well, lay the drone flat, and then you just say calibrate accelerometer.
Oh, excellent.
Yeah. All right, other useful info. We have firmware info. Looks like I can maybe use an update on this 2022 and other network stuff. Okay. The main thing from here I would say is the arming disable flags. And yeah, that's probably the main thing from the setup page after you calibrate accelerometer. All right. Everyone good on the setup page? All right.
So once you calibrate the accelerometer, does it automatically? So now,
It doesn't do it every time. It does it when you tell it to. So like right now, because we set it on a flat surface,
click on it.
we clicked it, it has calibrated to this surface. If you notice when you plug in the drone that it's like super tilted, you should recalibrate again. But you don't need to do it every time. It's just because we're kind of setting up this drone the first time. You need to calibrate it. Yeah. Okay, we're gonna go to ports next. Ports is the second section. Okay. I'm gonna actually switch to my slide here. You'll notice here in the ports that we have a bunch of UARTs. Okay. UART. Okay, so UART stands for Universal Asynchronous Receiver Transmitter. It's like a USB port, if you think about it, right? Sometimes the USB thing you plug in, it's sending data, sometimes it's receiving data, okay? So the same thing here for the drone world. We call it UART port, okay? Simple two-wire protocol for exchanging serial data. It's digital lossless. We only need 3 wires: power, signal, and ground. Okay. And if you recall from our receivers, when you wire it up, if you actually look at the drone, you guys know what the receiver looks like, right? It's that little square, and in my case, it's rapidly flashing green.
Yeah.
Okay. That's our receiver. Now you count, there's actually 4 wires. Do you guys remember why we have a 4th? Technically, we only,
No.
Nope.
No.
Technically, we only need 3. We only need power, ground, and signal, but we have a 4th. Yes. What is it called? So this is a receiver. So the signal is coming from the receiver to the flight control board. Using what protocol, by the way? Does anyone remember? From the receiver to the flight control board with this wired connection. Yes, that's right. That's the first letter. That's the second letter.
CRSF.
Correct. Okay. The reason we have a 4th wire is because of this thing called telemetry. I talked about it previously, which is you're sending data back to your controller. You don't need it technically. This is like a nice optional feature that this receiver has. You really only need 3, which is the point I'm trying to make here at the UART. You really only need 3 wires, okay? Now, it can handle 4, technically, if you use both a signal transmitting and a signal receiving, which in our case, we are. That's what we're doing right here, okay? When all of our input and output devices use a UART port, but not at the same time. So what's an LED light? Input or output? Output. So that's going to use 1 UART port. Okay, then let's put a servo motor on there for a gripper. What is that? Input or output? That's another UART port. You can't put it on the same one as the LED light. Okay, and then you have another device, a receiver. Okay, which is typically considered a input or output. Yeah, input. These are getting data from the receiver. That's going to go on another receiver or another UART port, okay? So every single device you put is going to be a UART port. GPS, that'll be another UART port, okay? Yeah, so fancier flight control boards have more UART. You need a minimum of 1 for the receiver. That's a minimum. Now, in our case, if you look at Betaflight, we have 5 UART ports. Pretty nice, right? We don't need all 5 because the only things we have plugged in, actually the only thing we're using UART port is 2 things. it's going to be the receiver, and in this case, I think this is using it for I don't see anything here. It's using it to configure either one of the VTX or some telemetry thing. Here, let me show you right here. These UART ports are mapped to a specific physical port on your flight control board. So look right here at this example. You see R3T3. This UART stands for what? It stands for Universal Asynchronous Receiver Transmitter. R and T, receiver transmitter. So what you're going to see is you're always going to see a pairing of receiver and transmitter. That blue box, that's UART3. The red box, UART6. So I must have a UART1, 2, 4, and 5 somewhere else around this board. You guys already have your drone assembled, but mine is exposed. If I was to look at the pad right now, so this is stuff you, I guess, typically would do as you build it. You keep track of what you soldered to what pad. I see here T1, T1R1. Okay, so this technically should be what you are. UART1, that's right. Okay, so let's take a look. When I go over here, okay, good. Now it's not going to tell you, oh, receiver, it doesn't know what you plugged in. You have to tell it what you plugged in. So we plugged in a serial receiver, so we have to turn on the serial receiver toggle, okay? You see, there's a bunch of other potential things you can plug in. You can be dealing with telemetry, you can be dealing with different sensors like an ESC or GPS, dealing with peripherals like these VTXs. But for each line, you can only have one thing turned on from each column. You can't turn on multiple things. You can only turn on one thing. So in our case, the device we plugged into UART1 is a serial receiver. I turned that on. Okay. So you can see right here, this particular blue row, we would need to turn on whatever the thing we using. There's nothing plugged in here, so I don't know. It's just an example. UART6 would be here too. You see right here, I see okay, they're cut off. It's cut off from this image, but UART1, 3, 1, oh, I don't know. 2 doesn't show up on here. Oh, you know why sometimes you might see a skipped? Is because it's been reserved for some specific sensor that's like kind of already it's already like a physical port. So some of these boards, they are like made to work with, for instance, like a DJI O3 system, and they already reserved UART2 for that, so you don't see it on here. It's like it doesn't have a solder pad for you. Okay. So that's in case you're wondering why it skipped. Where did 2 go? It's because it exists, it's just reserved for a specific application. It doesn't want you to reassign it to something else. In our case, our board is like pretty open. We have 1 through 5 available. Okay, so everyone using the school drone, because it's been pre-soldered, you should have serial RX turned on for UART1. And then this is the USB UART in a way. Okay. It's grayed out. You can't even like, you can't touch it. I don't know why this one's turned on for mine, but do you guys have that?
Yeah.
All right, just keep it on. Is there anything else? Okay. Yeah, sure, turn it on. Okay, that's it. We don't have anything else plugged in, but hey, if we want to get fancy, we have the ability to plug in 3 more device. I don't know what this one's used for, but let's say it's out of commission. So we at least have 3 more options. If we want to plug in a servo motor or LED light, we have the ability on 2, 4, and 5. If I look around this pad, I should be able to find a 2, 4, and 5. Yes.
So there's, for each, you can only give either input or output.
Technically you can use both. Like in our case, our receiver is using both, But when you use both, it has to be for the same device.
And I'm sorry, physically, when it's using both on the pad, like there's solder to both,
Yeah.
okay. But if technically, if you had like other components that you don't wanna use all the time, you could. Let's say you have an output device, and then like an input device. Could you like attach them separately to that and then just choose which one you're?
No. So, okay. So yeah, that's the catch is let's say you have an output only device, which is an LED light, and an input only device, which is, I don't know, what's an input only device?
GPS.
The GPS.
Yeah, sure. You can't split those two devices on the same UART port. Those are two distinctly separate,
Like
like,
you could have it installed and then choose not to be one of them.
no.
Oh.
You have to break it out per UART port. So one would have to be on a UART 3 and the other has to be on a UART 4. Even though you're not using both input outputs, they are
Can't split
two,
'em.
you can't split them. In our case, our receiver is like the same device, so it can utilize both, but you can't split it like, I want to use half of that UART port for the GPS and half of that UART port for the LED. Yeah.
So unless it's like a serial or an input output and it's using both,
Yeah.
it's always gonna be.
It's gonna be its, yeah, it's like its own distinct UART every single time. Even if it doesn't use both receiving and transmitting, it's if it's a separate like purpose device, it has to have its own UART port. Yeah. Good question, because that's a
It's the warning,
huh?
the warning that this is problems.
What warning? I don't get a warning.
TX cable, TX not set up.
Where? Oh.
So that's probably your.
Oh, okay, yeah. Okay, yeah, that's probably what here, let me try that again. Let me see.
Because if you go down the video transmitter, it says you have to set it.
Yeah, I mean, I turned off UART 3 now, but still, because usually you have to like do this. Okay, so what this warning is telling you is you can what is it? You can control the channel that your VTX is on through your flight control board, but it has to be a compatible VTX that can communicate with your board. And this what this is saying is it's a VTX table because you can go into here and you can create a table that maps what your buttons do to a particular frequency. So in our case, we're not, that's like the smart audio that he was talking about. But in our case, I don't think the classroom drones have that ability to talk. So you would just have to set it up as a separate like entity. It doesn't, you can't do it through Betaflight. If you could, that's convenient, but not all things support that.
It's a separate thing, but on presets,
Mm.
there's also like VTX tables.
Yes.
Flash to the ground,
Mm-hmm.
just to skip that.
You need to have like a compatible VTX in order to configure your frequency through Betaflight. So that's something you have to look up for each VTX. But I believe the one that we're using is not compatible. So we would have to manually go and change it outside of Betaflight. All right. It's like its own little bubble. Like it does the VTX job of transmitting, but it doesn't interface too well with the board in terms of letting you configure the VTX. Like I don't know. I just turned it off and like I'm gonna turn it back on again. I don't know why it's on. I don't know why it's on, okay, but it seems like everyone's is on, so I'm like, sure. We can play with it later. Once we get this thing working, I'll turn it off and see how it affects the things. I don't think it will affect anything, but well, let me look at UR3. My thing is exposed. There's nothing plugged into my UR3 right now. I'm looking at it. Huh? Just the receiver, just UR1. Oh. Actually, I take that back. Here, let me show you a camera. This might actually be necessary. Let me see here. Oh crap. I closed it.
Got
All right. Take a look. Do you guys have this port? Do you guys have this
Yes. Yeah.
look T3R3? You see right here? It's connected to that thing, and if you follow that cable, it goes to what device? Yeah, VTX. So I think it needs to be on for that purpose.
So do we need,
That port is being utilized for the VTX.
do we need a set on the peripheral?
No. No, we're just gonna use this to talk to it. Because this is actually not one of our options. We're using, yeah. So anyways, okay, do it exactly like I have it here. All right. Save and reboot. You can always do that to just push all the changes. Okay. Connect. Okay. That's ports. Questions on ports? All right, let me see what else I want to say about that. Okay. All right, next is configuration. Okay. Well, you wanna turn on the sensors if you have them. But if you look at the top, we don't have barometer, we don't have magnetometers, so if you turn it on, nothing's gonna happen anyways. So the only thing to turn on right now is accelerometer. Don't worry about the gyro and PID loop frequencies. Just leave those as is. Aircraft name. Here you can put a name, and the only time it'll show up is when you have your goggles. Okay, it's not like it's gonna show up on a screen somewhere on your drone. Okay, that's the only time the thing shows up is on your goggle if you care to have a name show up. Okay. All right, so I'm gonna call it drone creative. All right. Yeah, so that's from previous semester. They called it something else in case you have an existing name. Okay, camera angle. We don't have the ability to adjust the camera angle. You adjust it with your finger, all right? You pre-adjust it. But like assuming you have a fancier setup where you have it connected to like a servo motor where you can adjust it, you can, okay? Which would take a UART port, right? The servo motor, it'll take a UART port. So this also doesn't do anything. You can put whatever number you want. It's not going to move the camera for you. As you know, you assembled it. It's just a screw. Okay, arming angle. What this is saying is you don't want the drone to arm when it's like on the side, right? Okay, so what this is telling you is what is the maximum tilt angle that the drone will still arm? If it exceeds that angle, it's not going to arm. Okay, because it assumes that you're like sideways or upside down or something like that. Huh? So 180 basically says your drone can be upside down and it'll still arm.
Mine's on.
Okay, so I know like for racing they actually put it on these stands and the drone is like this to begin with. So, but even then, I don't think you need to go beyond 90 because this is 90 now, and now you're starting to go like upside down. So, if you want what 180 is the highest number you can put, and that just means it will always arm, regardless of the orientation of the drone.
Like 5.
Yeah, you can put 45. I don't know. This one's at defaulted or something at 25, so I'm keeping it there. I would say we're not like crazy racing, so maybe don't do such a high number. You can maybe set it at 25 like me. But just know what that means, all right? I would say set it at a lower number just because you don't want to accidentally arming when it's upside down. Later you can change that. Okay. Here is a bunch of different options. The only thing I think Yeah, the only thing I did was turn on the OSD on-screen display.
So mine has air mode turned on, though, the on or off.
Oh.
Yeah, same.
Huh?
I have the same.
I forgot what air mode does.
Question.
Air mode? Huh?
Allows for reaching it.
But Betaflight's so like vague.
It's,
so they just-
I know, there's just too many settings. I do not even know it all.
You can brick it on Betaflight pretty quickly.
Yeah.
Says, air mode maintains control authority at low or zero throttle by allowing the controller to continue adjusting motor speeds to keep the flow stable.
Thank you.
Before air mode, cutting. Um, I don't know. Here, let me see what this thing. Let's see what Oscar Lang has to say. What is air mode? Oh. I guess maybe turn it on. It seems okay. Sure. I don't know, like I'm kind of confused. Yeah, I'm kind of confused what the heck. It's something to do with some stability when your throttle's zero. On or off? I don't know. Okay, yeah, this only matters if you're gonna dive, it seems like. I don't think we're doing that here. All right.
And like lighting,
Huh?
like lighting the drone at like a, they're like.
No, diving is like free falling basically. Yeah, when you like pitch down and then you're just like
But the motors are not engaged when they're diving like that, right? They're kind of-
right. Well, that's the point of air mode. It seems like it still like keeps it on so that you have some level of control. It's not like just falling like a brick. Um, I would keep it disabled. It seems like when flying tiny whoops indoors or when landing, you should turn air mode off. That's gonna be more applicable to us than the diving. Yeah, I would just keep it off. You can play it with your on your own time. So OSD is the only thing I have on. That's okay. Okay, this board alignment. Assuming you did not mount this board correctly, or you couldn't because of some like let's say the USB port would have been blocked, so you have to like reorient it. This is where you can adjust the orientation. But because we all put it right side up, arrow pointing forward, you can keep these at zeros. All right. I should go back here to ask you guys to check. When you go to setup and you tilt your drone forward, the arrow points to the front of the drone first off, right? You guys confirm that. If it doesn't, and if you go left and right, okay, it should reflect whatever you're doing in reality. If it doesn't, that's when you can go into configuration and you can adjust the board alignment. So if you need to flip it or rotate it or whatever, this is where you make that adjustment. Same thing here with the accelerometer and the IMU. If you need to change the gyroscope. Okay, but everything here is just default zeros because we orient it correctly. Okay, trims. Trimming is when you're making micro adjustments to the leveling. So on the controller, we actually have these little like buttons here on the right and on the bottom and to the side of the sticks. This allows you, if you like have the sticks at 0 and the drone starts to drift, you can push it in the opposite direction to get it to like just stay steady. That's what trimming is, okay? You can also do the same thing here on the accelerometer, but we just calibrated the thing and we haven't flown yet, so just keep it at 0. Make sure you're zeroed out. But like, let's say for some reason you calibrated it and it's still like tilting and drifting, you can adjust it here a little by little. This is meant to be slight adjustments, not a major calibration. All right. D-shot beacon configuration. Okay, you heard the doo-doo-doo when you turn on your drone. Okay, so that's actually the motors vibrating and it's making a particular music out of it. Okay, so you can change the music. You can even you can look it up on your own later, but you can even like create your own custom music. Like you could put a Star Wars theme song or whatever you want on it. Instead of having their default do do do, okay, you can do something else. All right. Um, so that's a separate ESC software. That's not part of Betaflight, but yeah, you can configure it later. Okay. Um, you can, okay, so that's when we say beeping. The beeping is actually from the motors. There is no beeper built in. It's just the motors vibrating. So next time you plug in the battery, hold your hand to the motor and you'll actually feel it vibrate. Okay, so you can have it beep when the signal is lost. That's what this is saying. Or you can beep it when you set a specific channel on your radio to it. Okay. I just left these at the default, which is off and beacon tone 1. Okay. Remember D-shot? That is our ESC protocol. Okay. D-shot. Okay. Very good. Beeping configuration. These are things that the drone will beep if any of these conditions are met. I guess I turned them all on. Yeah. All righty. Any questions on this page? All right. Very good. Power and battery. Well, we don't have a battery plugged in, but when you do have a battery plugged in, this will show you what the total voltage is. Keyword is total. It does not know your cell voltage, okay? Because you're only plugging in this main port. If you need to know the cell voltage, you need to be able to access the individual balance ports, okay? But the drone doesn't have a place for you to plug this in. So it's going to know the total voltage and it's even going to tell you. So here, I'm going to plug this in just to show you. Oh, I need a good battery though. Let me, here, I got one here. Okay, so you can look at here when I plug in my battery. Okay, look at this. Oh, this is not right. Okay, it says 11.26, but this is not a 3S battery. This is a 4S. Okay, it's approximating. What it's doing is it knows each battery is offset by 4.2 volts. Or sorry, yeah, basically between like 3 to like 3.5 to like 4.2 volts. Okay, it knows the jumps. So it's seeing here, oh, it's 11.2. So the closest thing is the 3S. But this is probably just the battery that's not very well charged. So let me get a different one. Because this is supposed to be a 4S battery. Okay. Let's see. You see it's climbing, it's climbing. Okay, see this says it's a 4S. Same exact battery, but it's just guessing. Okay, because that's it. All it's doing is I'm plugging in the main power. And if I fall between okay. What's my ranges again? My range is so 1, 2, 3, 4. And then this will be somewhere between 3.5 to 4.2, right? We agree on that? And then this will be times 2, which is like 7 to 8.4. This will be times 3. That will be 10 12.5, right? To 12.6, and then this will be 14 to plus another 4. So it would be 16.8. Okay, so what's my voltage here? Let's just say 15, 14.99. It knows it's a 4S, or at least it guesses it's a 4S, right? So the problem was like this one was too low. It was like 11 point something, so it thought it was a 3S, which now I'm concerned I might need to charge this up. Let me take a look here. Um, okay, one of the cells is dead on this actually. Because I'm only reading 1, 2, and 3, and then that's it. So that's a problem. Okay. All right. So that makes sense why it was so low. I'm like, even at the low end, it shouldn't be below like 14, right? But okay, that's a pity. All right, so here we have our battery, and this is the stats. Okay, I'm actually gonna unplug this. Okay, make sure you unplug your batteries because your VTX is gonna start heating up. I can even feel the heat right now. Okay, so just try it briefly and then unplug it again, please. All right, because we're not breaking out the fans and stuff yet. All right, touch your VTX. It's hot. Mine is hot. All right. Yes. Okay, so you notice that at the top, the battery doesn't know individual cells. So it's going to approximate. And this same thing applies here. It's going to assume a particular number of cells, and then it's going to divide by that number of cells. And then if the average becomes one of these values, it's going to start to trigger something. So this would show up on your VTX goggles. It'll be like, oh yeah, warning, you're getting low. Or yeah, so anyways, that's that. Okay. So you can set that here. Yeah, that's about it. Okay. That's about it here on the battery. So when you're flying your drone, I would recommend you turn on 2 voltages, the total voltage as well as the per cell voltage, knowing that the per cell is not truly per cell. It's just the total divided by what it assumed the number of cells it has, okay? So just keep that in mind. All right. Okay, so if you don't have failsafe, you're gonna have to turn on this enable expert mode. You see this little toggle right here? When you turn that on, kind of let me dim the light a bit. Okay. All right. When you turn on the expert mode, then you'll see the failsafe. Okay, previously failsafe, what I mentioned about this is the kind of the return to home mode that gets triggered in the DJI system. Except for you to return to home, you need GPS, which we don't have. Okay, failsafe is, as the name implies, trying to prevent you from failing completely. And there's 2 stages to failsafe. Okay, stage 1 and stage 2. Stage 1 is the initial stage, and that's triggered under a couple of different conditions. If you read here, it'll tell you invalid pulse length. What this is saying is your receiver or your transmitter is sending pulses of signal to your receiver, and it expects these information to be in certain packets. Okay, and if you're getting drop packets, then it's going to say something is wrong. I'm not getting all the information I expected. Like let's say you expect a packet to show up like several times a second, and then it's like let's say there's like 50 packets per second, like 50 hertz, and you only got 48, it's like, oh, something's going on. I dropped a couple. All right. So the, huh? Yeah, exactly. Yes. Um, that's the first condition, okay? The other one is the receiver reports a failsafe mode. So what you can do is you can purposely tell the thing enter failsafe. Just like on a DJI drone, you can purposely say return to home. You don't have to wait until the battery goes low. All right. So that's the second condition. And the third condition is there's no signal at all. That's pretty bad, right? Okay. Same thing on a DJI drone. If you have no signal, it's going to also trigger the return to home. Okay. So those are your three condition. And then what's going to do is it's going to enter stage one. Okay, here's the valid pulse range settings. Okay, so this is like it's expecting somewhere, if I had to look at this, it's targeting something like between 1,000 and 2,000. And this is kind of like the lower and the upper limits of that. If you fall outside of that, then something went wrong, basically. Okay, so I don't know how they came up with these numbers, but I'm just keeping it here as now. Like, yeah. I think this is just I don't know, like, yeah, I don't know where the numbers came from, but I'm sure it's targeting 1,000 to 2,000, and this is just a buffer of, well, actually, it makes sense. It's a buffer of 115 in both directions. So 1,000 minus 115 gets you 1,885, 1,000 over 2,000, 115 gets you that over 2,000. Okay. So yeah, it's obviously targeting the 1,000 to 2,000. Okay. Now, what's going to happen when it enters that stage one? Okay. Oh, wait, before I do that, okay, yeah, sorry. Here are our main settings, right? Do you guys understand the different motions of the drone? Roll. Roll is the sideways motion, okay? Pitch is the forward and backward motion. Yaw is when you're like the equivalent of you turning your head, okay? You're not like moving the drone around, you're just reorienting the drone. Okay, that's what yaw is. And then throttle is up and down. So it's going to, because it didn't receive the proper signal, it's going to have to make an assumption of what it should do for these main motions. Okay, so auto, in this case, if you read, it says it's going to center the roll, pitch, and yaw. Well, that's good, right? Don't you want the drone to like hover? Essentially, that's what it's saying. It wants you to hover if it doesn't receive a signal. On the other hand, throttle is low. So actually, it's not hovering. Rather, it's leveling off and lowering, or rather, leveling off and dropping like a rock. Okay, that's not that great. Okay, but throttle low. If you don't like that, you can hold it at the last known value, which could have been you accelerating, so it could shoot up, or it could have been you like cutting it and it's only going down. If you don't like that, you can set it at a specific value. Now, I haven't got to that tab yet, but the range from low to high on Betaflight is not 0, 1, 0 to 100. It's 1,000 to 2,000. So low is 1,000. That's essentially your throttle is cut, and high is 2,000. Your throttle's all the way up. So 875 is going to be treated as the equivalent of 1,000, which is just you cut. But let's say experimentally you found out that the hover point is like 1,200. Okay, you can set it here so that now the drone is leveled and somewhat hovering. Okay, if you don't like the fact that auto is going to lower the throttle, you see right here, auto is going to keep throttle low. If you don't like that, then you can set it to a specific throttle. But you need to find that experimentally what that is. Okay. You don't have to like put into failsafe to find out what the throttle is hover. You can turn on a specific OSD setting and you can find out what that throttle value is, and then you can put it into here. Okay, when you're flying under a controlled manner, you can find out what that is. Okay, so for now, I just set it to all auto. So what's the drone gonna do in this case? It's gonna hover, but not in place. The throttle is low, so it's gonna actually start dropping. It's going to level off, but start dropping. Okay, that's what I'm saying. If you don't like the fact it's dropping, you can set it to a particular value so that it's hovering. But the reason it's probably doing this is because, well, you want to retrieve the drone, right? And if you like set it at a hover, it's just gonna stay hovering, and you're just gonna look at it and be like, great. So I think that's why they set it to like low throttle so that at least you can still get the thing back. Yeah.
Do FPVs actually like hover? Like, you know how they.
Not really. Yeah. So if you guys flown an FPV drone, they don't like the hover is more of like a slow ascent or slow descent. It's very hard to like because hovering requires like a constant jiggling to like keep it like going. Yeah. And it always is environmentally dependent. So in one environment, your 1200 might work, and in another, it may not start. Yeah. So it's if you look at our sensors, what do we have? What's our sensors? Gyro and accelerometer. This does not tell you height. If we had a barometer, it can hover. We don't. So this drone is not going to hover on its own. It can level itself out and it can slow to a stop, but that's about it. It has no idea if it's falling or rising. Yeah. If we had a barometer, then yeah, that'll be good. It can hold its spot. Okay. We also have a bunch of auxiliary channels. Auxiliary channels are things that we can map out, which we haven't done yet. You can map these out later, and you can also determine what to do. Notice there is no auto this time because auxiliary are all custom settings. So Betaflight doesn't know, and it's not going to make an assumption of what it should do in each auxiliary channel. It only gives the option of holding the last thing, or you can set it to a particular value between 1,000 and 2,000. So the safer conservative thing is to hold whatever the last thing you were doing. If you were in angle mode, keep it in angle mode. If you're armed already, keep it armed. So that's what the hold is doing, all right? Okay, that's stage number one. Stage number one's kind of like this grace period. Okay, if you look here at the next one, stage number two, if after this period of time you do not get a valid signal again, it's going to enter the more severe stage two. So it's giving you a 1.5 second grace period to recover. In case it was just a fluke. Okay, maybe it was just a one-off package lost. Okay, no big deal. If within 1.5 seconds you get valid packet again, it's going to kick out of failsafe and back into normal mode. All right. And everything is all good again. But if it doesn't, it's going to enter stage two. All right. And then in stage two, you have the option of either dropping the drone where it's at. So basically cutting the throttle, or in my opinion, gracefully landing is a little bit better. Okay, so that's why I selected that. Gracefully landing. And if you had a GPS, this is what I was saying earlier in our discussion. If someone was to try to like, jam or overpower your video signal, keyword is video. Because if they overpower your like controller signal, you can't even like tell the drone, oh, I want you to come home. Because that's the thing that's been screwed with. But if they message your video and you still have control of the drone, you can be like, okay, I'm gonna say turn on failsafe on purpose. And if I set up GPS rescue, it'll still come home. But you need a GPS to do this. We don't have a GPS. So you can click on this. And actually, I don't know what would happen if you click on it because we don't have this. So I don't know if it's going to default to the land or the drop. No idea. So Put it to land. But the key thing about landing is you need to know what throttle value allows your drone to gracefully come down. 1,000, remember, is considered basically zero. So as it is right now, this is basically the same thing as me dropping the drone. Okay. So I know it's not 1,000. It's also not 2,000 because 2,000 is making the drone go higher. So you got to find that experimentally. Uh, you might think that the throttle should be midpoint, 1,500. But from experience, it's generally not. It's going to be between like 1,200 to 1,300. All right. So in case that surprises you, like don't be surprised when you find out, oh yeah, it's like not 1,500. It's not midpoint. It's somewhere lower. All right. Any questions on failsafe? Do you guys understand the three conditions that trigger a failsafe? What are they? Loss of signal. Yes. Loss of signal. Okay. Yes. Corrupt packets and stuff, right? Yeah. Or they call it improper package length. All right. Invalid pulse length. Okay. What's the third one? What's the third one? That's a good one, but not necessarily actually. This
Override.
Yes, you assign it to a switch. You like actually like purposely tell it to enter that mode. In case, for instance, you want to do a GPS rescue. You want to do something like that. Yeah. Okay. So those are the three conditions. It's going to first enter failsafe, and then after, in this case, 1.5 seconds, is going to enter stage 2. All right. Good to have. Good to have the failsafe. Right. So back to the setup. Remember this thing we saw is said, hey, look, my PWM whatever disable flag went away. Okay. Oh, it's probably because I plugged in my battery and then like I don't know, the motors found themselves or something. Okay. So at this point, the only thing we have is an RX failsafe. It's entered failsafe because there's no signal, right? That's one of our failsafe conditions, right? There's no signal. So that's what happened here. Oh, it's nice. Actually, I guess you can hover over it and it tells you what it means. Okay. Good, good, good. All right. That's fail safe. Okay. Presets. Presets are well, I haven't covered everything, but this allows you to import what other people have already made in all their settings. That's what it is. Okay. So far we covered some of the settings, but this can apply to any of these things. Okay. So yeah. If you want to use other people's setting, you can use a preset. That's what it is. All right. Okay, so I'm just gonna leave it as is. No preset. We'll just set it up manually. All right, PID tuning. That is what I intend to teach for the advanced stuff. All right. PID stands for proportional, integral, and derivative. This is all calculus math stuff now. Okay, this is a controls class. All right. Inverted pendulum, you guys know what that is? That's like a mall cop Segway. It's an inverted pendulum. It's inherently unstable, but because they have like a inverted pendulum is like, you try to like balance this thing, right? Like it wants to normally fall down, but like because it controls, you can like keep it upright, okay? But that's the theory behind PID. It gets kind of complicated. So we're gonna skip that. And that's where you want to use someone else's presets. They already tuned the drone. Okay. Just to give you an overview of why you might want to tune the drone. For instance, your drone, even at hovering, is like shaky. Okay. Or your drone is very sluggish. It doesn't move it doesn't move instantaneously, or it takes forever to like kind of settle down to a stop. That's when you need to look into your PID tuning. Okay. So, but there's so many levers that when you pull one thing, it starts to affect the other. It gets kind of complicated real quick. So, anyways, if you have any interest, of course, Josh Barwell has a video out there if you want to watch it. Okay, but it's like pretty long. Okay, we're gonna skip that. Okay, I can't really do this without talking about this receiver stuff. Okay. Uh, I feel like the rest of this stuff I need to wait until I cover particular topics. Okay. That might be it for the receiver side or for the Betaflight side. Let me see if there's anything on here. Okay. Yeah, I think I'm gonna have to go over this next time on the controller for us to proceed forward with the receiver and the modes, okay? Because I need to explain this on its own before we can even get into that. Okay, so that's gonna take a decent amount of time. Okay, so let me see if there's something else I can go over in the meantime. Da, da. Okay. Maybe. Okay, I'll just do this. That way we can get straight to the controller next class. I just have a few slides on the controller itself. Okay, so I'm done with Betaflight. Do you guys have any questions? I'm done with Betaflight for now. So far, we covered like about a third of the stuff so far. Okay, there's still a bunch of other stuff down here. Any questions? No? Okay. All right. Now, just to give you a more general overview, I mentioned Pixhawk. Pixhawk is like a whole different hardware. It uses a different software to program it. Betaflight is what we primarily use for any of these like more, I would call simple flight control boards or FPV flight control boards, which are manual. We primarily using Betaflight. It's open source. It's well adopted into the community. So that's why you see it a lot. Okay. It's not the only thing out there, but is the primary thing out there. Okay. Just letting you know we're only living in this FPV world right now, but there's a bunch of other software and hardwares out there that you could potentially use. Okay. Uh, all right. I'm going to go over briefly about radio controller, which you guys all have one, right? You guys have radio controller. Okay. We're not going to turn it on, so you don't need to like, you know, mess with it. That's what I'm talking about for Thursday. But I just want to point out a couple features. Yes, question? Yes. Yeah. If you guys are done, you can disconnect from video. I just want to talk about a couple of features of this controller. So that way we can speed up what we do on Thursday. Okay, when you're looking at controllers, there's a bunch of different considerations. Ergonomics, how well does it feel in your hand? The gimbals, which is the actual like bearing mechanism here. Switches, knobs, dial buttons, what type, how many do you have? And external module support. So when we talk about the gimbals, we're talking about this stuff right here. The two sticks, and they have bearing in there. And also they have a sensor to tell you like how far you push the stick. There's two main types. There's a potentiometer, which anyone work with electronics, it's actually just the variable resistor. That's what it is, okay? It's cheaper, but it wears out faster because there's actually physically brushes touching. Then there's a Hall effect sensor. Hall effect sensor uses magnets, so there's no physical contact, and that's why it's a lot more smooth and a lot more accurate as well. Of course, it's also more expensive. That's generally how things work. But the good thing is it's not like a crazy amount expensive. So even I believe all of the ones we have here are Hall effect sensor. If you look at your box, the controller box, I think it says Hall effect sensor on there, right? You have your controller up. If you don't mind looking, I believe it's a Hall effect sensor. So to give you guys an idea, the Radio Master Zorro, I believe it's like only $150, something like that. I say only because like compared to your goggles, which is like $500 or something like that. Like this is relatively like okay. But yeah, Hall effect sensor is like I would say more of the norm. And if you really cheap out like some of these other controllers, that's when you might have like a potentiometer, like some of these cheapier controllers are probably just potentiometers. Okay. Generally, you could tell it's cheapy because, well, look, this thing doesn't even have a screen, and it only has like a couple of buttons on it, buttons and switches. So same with this. This literally only has like two. This one's maybe a little better, but these ones I generally consider to be cheaper ones. Okay. All right, stick modes. This is just telling you what each stick does. In the US, we're using mode 2. Okay. Mode 2 means that throttle is on the left, up and down. Pitch is on the right, up and down. The other one that's generally used more like Europe is mode 1. Okay. So make sure we'll set that up on Thursday. We are in mode 2. They should all be in mode 2 because I told everyone to do mode 2. I know some people do mode 3 because that's like what they're used to for video games or something like that, but don't do that, please. It's going to if you like give someone else the drone and then they're used to flying mode 2, they're gonna screw it up. Yes.
There's an individual from that last class who flies inverted.
Oh,
That's how I have my drone simulator set up on.
mode 3. Well, it's not standard, so if you're going to end up like flying someone else's drone or whatever, you're gonna run into issues. So my recommendation is train your mind to do mode 2. Yeah. Yeah. Okay. So that's not physically changing anything. That's just assigning what is what. That's all software based, okay? Okay, switches. This is the most common thing that you have on your controller. Switches, we have discrete. You guys heard of discrete in computer science yet? Have you guys used discrete variables, things like that? No, you guys are taking programming class, right? Or you haven't got there yet? Okay. Discrete basically means it's distinct values. In this case, it's either on or off. Just like a light switch. That's a discrete switch. On or off. Okay. Now in this case, we can even have a third option. So I don't know, on, off, and mid, whatever. So we have two position switches. 1, 2, 1, 2, 1, 2. Or you can have a 3-position switch. 1. This one has yeah. 1, 1, 2. Okay, 1, 2, 3. It has 3 positions. Okay, that's the most common type. I haven't seen a 4 or 5. But yeah. Those are toggle switches is the one with the little paddle. And then we also have buttons. That's another form of a discrete button. The button can either be momentary, which means that as soon as you let go, it pops up again, or it can be latching hold. All right, so when you push it in, it holds its position. When you push it again, it pops back up again. Okay, so those are the two. Those
On mine, I don't have buttons, but I have like rolling switches on.
Okay, well, that's a continuous. So that's no longer discrete because when you roll, it's going to be a number between like 0 to 100,
Okay.
right? So when you roll it, you don't know exactly what value you're at. Versus like when you hit a switch, you know you're either one or the other. So rolling is a continuous, and it's going to be either dial, like you were saying. If you guys flown the DJI drones, the camera pitch is what? It's a dial, right? It's a dial right here. Or you can also have a knob potentiometer right here. There's a knob right here, you see? Same concept. There's a knob. Okay, but both of these are continuous because unless you turn it to the extreme, in between, you don't really know with certainty what value you're at. It's useful for what though? Like, what's this continuous useful for? I mentioned one application, gimbal. What's something that you want a variable value?
Could you use that for a payload or is that?
Yeah, you can be like, let's say this is controlling like the speed at which the winch is pulling up and also the direction. So you can be like, this one actually centers in the 50%. So if I pull down one way, it can release. And the more I pull, the faster release. And if I pull the other way, it will retract. Maybe LED.
Better.
Yeah, it could be like LED brightness. So I want somewhere between off to on, like a dimmer switch, volume, things like that, right? Something that has zoom. Yeah, exactly. What about for discrete? What's something you want discrete for?
Or, flight mode?
Flight mode. Let's say it's manual or level mode, right? You don't want to like turn the knob and guess at what point it reaches one flight mode or the other. You want to have with confidence. Hit this switch to this thing and it goes to that flight mode. Arming is the basic thing you need to always program. You need to know with certainty, is it armed or is it disarmed? Right? So that's a discrete thing. Okay. All right. Turning on and off a speaker, turning on and off failsafe, right? That's something that you want to know with certainty. Okay, so the beauty of this is that you can assign this to whatever you want. That's done in Betaflight, okay? Okay, we also have the ability to expand beyond the built-in protocol. So the drone controllers that you have here, the base it says 4-in-1, right? You see that? On the box, it says 4-in-1. So this is what we call a multi-protocol radio. It can talk to 4 different types of 4-in-1 protocol. It's actually more than just 4 protocols. It's 4 groupings of protocols, okay? So it's 4 distinct radio frequency chips, which translates to over 70 protocols. Unfortunately, ELRS is not one of those. Okay, this is more of a legacy thing, which is why if you look in your box, you should have a little white module. Okay, that module, if you look at it, yes, that thing, what does it say on there? It should say ELRS 2.4 gigahertz.
Oh, yeah, that's it. I'm back.
Yes, exactly. So that gives this controller, which normally does not have ELRS among the 70 protocols, it gives that ability to talk to ELRS. So that's what an expansion module is. They come in 2 different sizes. We have the JR full size, which is like this big. And then the ones that you have here is the light module, the nano micro size. Okay. That's the one that we have.
Xbox 360.
Huh?
Got it.
Yeah. And look at the connection on that. If you look at the gold connection at the top, remember my previous slide that I mentioned? That is a SMA. Let me see if I can pull it up. Right here. Does it look like the SMA? RPSMA. Okay, so that's because you have an antenna. Okay, so this is one of the connections I was talking about earlier. Okay, very good. So yeah, that's an intro to the controllers. Yeah, so the ones that we have is Radio Master Zorro. You look right here. Oh, it's even cheaper now. $100. Okay. All right. Well, look at this when you do go to buy one. Okay, I just mentioned this. You have the options. You could do the 4-in-1, which is what we have. Or you can just buy it straight as an ELRS. If you buy it straight as an ELRS and you're using only ELRS, then you don't need that expansion module. You're actually good to go. All right. But because we bought it as a 4-in-1 and the things we're using is ELRS, that's why we need the expansion module. Okay, you also need to make sure your thing complies with the open frequencies. So we're in the US, so it's FCC. I don't know what LBT is, but it's not here, is all I know. Another thing you have to keep in mind, this is where it's another gotcha if you're not aware. These typically don't come with batteries. It's super annoying until you find out the hard way. Yeah.
Takes like 3 weeks now.
Yes. So it doesn't come with a battery, okay? So you can see they're trying to pair it with you, okay? You need to buy a battery. Super annoying, all right? I think I told you about that, right? Yeah, it doesn't come with a battery, okay? So just keep that in mind. The good news is typically these you can charge with USB-C. So you don't need to like, like plug it into the charger like I was showing you with the other batteries, okay? Um, yeah, I don't know. I just wish things were nice and come simple, but that's how it is. That is crazy. Look at how much the Hall effect sensor is. I might as well just buy another controller. It's $100 just if you need to replace this thing.
Yeah, it's TX12 controller.
And Zorro.
Yeah.
And this is the Zorro for another $20, you get the whole new thing. I don't know. That doesn't make any sense to me. But okay, whatever. Yeah. All right. So Radio Masters is a pretty big brand out there that makes a lot of controllers.
Have you seen their new AX12 controller though?
No.
It's the RC2 controller, but for DJI mixed with the TX16.
Oh wow. Look at that.
So you have Android.
Oh wow, yeah.
Android
Yeah, it does
system.
look like a DJI controller.
The guy that did the RC2 controller, like, did this with them.
Oh, okay.
Literally, like, the screen is the same functionality.
Oh, really?
It's really nice.
Well, interesting.
The rules are identical.
Yeah, it looks very familiar. Well, look, this is how you know ELRS is the only option they even have for this. So that's why I keep like recommending that because that's like if you want to future-proof yourself a little bit, they don't even have an option for other stuff.
You can't fly, like you can't use a DJI 043 unit, right, for that, or you can?
No. Yeah, you have to buy DJI if you want to use any DJI stuff. Yeah. This is probably just a nicer screen than the ones that you guys have. That's
It's got full.
it's not for video, is it?
No, it's full Android.
No, but is it also meant to be like a video receiver, the screen? I think it's just literally a receiver. I mean, I think it's literally just a nicer screen. I don't,
I've seen videos on it, like, you can go on YouTube on it. Like, you can also broadcast.
but does it takes video? Like it acts as a goggle system?
I think it does, 'cause you can use it as a camera, like, it's to take photos. Yeah.
Really? Oh wow, look at that. I mean, I don't know why we didn't have this earlier. Honestly, I feel like right, I feel like sometimes I don't need the overkill of a goggle system, which is so annoying on its own because it's like another device, another battery, another cable dangling all over the place. Yeah, but I would say like if you're trying to do like mapping or something that doesn't require like 100% focus on.
You can't really map with an FPV.
Well, but if you build a custom drone and then you use this thing,
I mean,
um,
if you could use that to set waypoints, do all kinds of stuff.
okay, let me see here. It seems like it's kind of requires you to pass it in via HDMI rather than it doesn't have its like own like built-in VTX receiver. It seems like I saw an image down here that seems to confirm that. It seems like you can put a goggle into there. You still need a goggle. I don't know.
Is it free to receive video transmission on like a desktop?
Yeah, but you still need an external module to receive the signal, and then you could pass an HDMI in, like what they're doing here. Yeah, so the laptop inherently will not do it. You still need a module to
A dedicated one.
yeah, dedicated one to receive the video signal, and then you can patch that in from your computer to your computer.
They sell those little screens too on Amazon.
Yeah, yeah, they do. Yeah, with the built-in antennas.
Yeah, yeah.
Yes, yes. Okay, I think that's all I want to show today. So if you're not done building, you can keep building or you can go. All right, yes. Thank you.